Part 3, Genetics and Age of First Drink. Are you predisposed without knowing it? Two people can drink the exact same amount of alcohol and have completely different outcomes. One wakes up with a mild headache and moves on with their life. The other slowly builds a habit that turns into a dependency without ever planning to. Why? It often comes down to genetics, and something most people never think about. When you started drinking, the enzyme that changes everything. When you drink, your body needs to process ethanol. Step 1 is converting it into acetaldehyde. Remember the cellular wrecking ball? The enzyme that does this is called alcohol dehydrogenase ADH. If you have plenty of ADH, you can process alcohol faster. This means you might be able to drink more before feeling drunk, but it also means you might drink more often, increasing long-term damage risk. If you have very little ADH, common in certain East Asian populations, even small amounts of alcohol can make you flush red, feel nauseous, or get a pounding heartbeat. In this case, you're less likely to drink heavily, simply because it feels bad. Ironically, being able to handle your alcohol isn't a badge of honor, it's a potential danger sign. If you can drink a lot without feeling sick, your natural brake system is missing. That means you can more easily slide into patterns of frequent, higher volume drinking. The Energizer risk profile. We already talked about the energized drinker, the person who feels more alive and upbeat the more they drink, instead of sleepy. This is partly genetic. If alcohol increases your alertness instead of sedating you, that's a big red flag for higher addiction risk. Your brain is essentially wired to give you a bigger reward hit from alcohol than the average person. The age factor, why starting young changes the game. Here's one of the most sobering statistics in alcohol research. If you start drinking regularly before age 15, you are 3 times more likely to develop alcohol dependence later in life, even if no one in your family has a history of alcoholism. Why? The teenage brain is still wiring its reward system. Introducing alcohol early hard-codes patterns into those circuits that can last for decades. Even starting at 16 or 17 increases risk compared to waiting until 21. And if you do have a family history of alcoholism, starting young stacks your genetic and environmental risks together. The takeaway for anyone listening: if you have a close relative with alcohol problems, or if you started drinking in your early teens, you're statistically on a steeper slope toward dependence, even if you feel in control right now. This isn't about willpower. It's about the way your brain and liver are built, and the way alcohol exploits that biology over time. Next, we're going to tackle tolerance, why your buzz gets weaker, your hangovers get worse, and why drinking more to feel the same actually speeds up alcohol's most destructive changes in the brain. Tolerance and the pleasure, pain balance, why the buzz fades and the crash grows. Tolerance sounds harmless. We talk about it casually. Oh, I've built up a tolerance, I can handle my liquor. But in reality, tolerance is your brain's warning flare. It's the sign that alcohol is quietly re-engineering your reward system, making pleasure harder to reach and pain easier to trigger. The dopamine story. Every time you drink, alcohol triggers the release of dopamine and serotonin, the brain's feel-good chemicals. That's the buzz. You feel lighter, more social, maybe more confident. But here's the catch. That dopamine spike is short-lived. As soon as it peaks, your brain's balance tips the other way, into a deficit. You enter the afterbuzz, a longer period of lowered mood, motivation, and energy. Your brain does this to protect you. Too much dopamine for too long can be dangerous, so it compensates by dampening your reward circuits. The pleasure-pain balance. This is what addiction specialist Dr. Anna Lemp calls the pleasure-pain balance. Every hit of pleasure tips the seesaw one way. Your brain automatically pushes back the other way, creating pain or discomfort to restore balance. With alcohol, the pleasure side gets smaller over time, while the pain side grows. That's why your buzz fades faster. You feel worse for longer afterward. You need more alcohol to feel the same initial high, but you never really get it back. The tolerance trap. The brain adapts to repeated alcohol use by releasing less dopamine in response to alcohol, increasing the number and sensitivity of pain pathways, stress hormones, anxiety circuits, irritability triggers. speeding up alcohol metabolism in the liver through more alcohol dehydrogenase production. So now you're processing the alcohol faster, feeling less pleasure from it, and feeling more discomfort without it. The result? You drink more often, not to get high, but just to feel normal. The good news: for most people, if you stop drinking for long enough, your brain's reward system can reset. In light to moderate drinkers, dopamine balance can recover in weeks to months. In heavy, long-term drinkers, it may take many months or even years. But here's the key: tolerance is reversible, if you give your brain and body the break they need. Next, we're going to talk about one of the most relatable and misunderstood parts of drinking: hangovers. They're not just a morning after inconvenience. Hangovers are your body's alarm system, and understanding them can change how you see alcohol forever. Hangovers and recovery, your body's morning after alarm system. We joke about hangovers: the pounding head, the dry mouth, the stomach that feels like it's plotting revenge. But a hangover isn't just your body saying you overdid it. It's a full-blown multi-system emergency response, a chemical, hormonal, and inflammatory storm telling you something is very wrong. The chemical backlash. When you drink, ethanol is metabolized into acetaldehyde, remember, the cellular wrecking ball that's even more toxic than alcohol itself. While your liver works overtime to turn acetaldehyde into acetate, the stuff is still floating through your system, damaging cells and triggering oxidative stress. This process releases free radicals, unstable molecules that attack everything from your DNA to your cell membranes. The result: inflammation throughout your body, including your brain, dehydration and electrolyte chaos. Alcohol is a diuretic, which means it tells your kidneys to flush out water, and along with that water go your electrolytes: sodium, potassium, magnesium. These aren't just nice to have. They control muscle contraction, nerve signals, and even heart rhythm. When they drop, you get muscle weakness, headaches, dizziness, and in extreme cases, heart palpitations. Blood sugar crash. While you drink, your liver is too busy detoxing alcohol to keep your blood sugar stable. Hours later, that can mean a sharp drop in glucose, leaving you shaky, sweaty, and mentally foggy. If you've ever woken up from a night of drinking with trembling hands and a craving for something greasy and carb-heavy, that's your body scrambling to stabilize blood sugar. Inflammation in the brain. The hangover headache isn't just from dehydration. It's also neuroinflammation, your brain's immune cells, called microglia, going into overdrive in response to alcohol's damage. Inflamed microglia don't just make you feel lousy, they can temporarily affect memory, mood, and focus. Why hangovers get worse with age. Ever notice that hangovers in your 30s, 40s, and 50s hit harder than in your 20s? It's not just nostalgia, it's biology. As you age, your liver processes alcohol more slowly. Your body contains less water, meaning each drink produces a higher blood alcohol concentration. Recovery systems, including antioxidant production, slow down. The result: longer, nastier hangovers, and greater risk of long-term damage from the same amount of alcohol. The myth of the hangover cure. People swear by greasy breakfasts, electrolyte drinks, hair of the dog cocktails. The truth: the only real cure is time. Your body needs to metabolize the remaining alcohol. It needs to process and clear acetaldehyde. It needs to rehydrate and rebalance electrolytes. While things like water, electrolytes, and light food can make you feel better, they don't speed up alcohol metabolism. Your liver can only work so fast. The wake-up call. Hangovers are a signal that your body endured a massive internal stress event. Every hangover is not just discomfort, it's evidence that your organs, your nervous system, and your immune system were all pushed to their limits. To be continued in Part 4. If you like this video, be sure to like and subscribe.